Hello everyone, this is Gayatri Priya, Assistant Professor in the Department of ECE of RMD Engineering College. In today's sessions of analog electronics, we are just going to discuss about the basics of oscillations. Right. What is first of all an oscillator? It is basically a generator which is going to generate an output signal that has the capability to oscillate. Oscillate in the sense it will be having some constant amplitude and up with the desired frequencies. As discussed in the previous session about the positive or regenerative and negative or degenerative feedback, if an amplifier employs positive feedback, that is, without applying any external AC input signal, it could produce a AC output of desired frequency. This is the basic theory of oscillator consisting of a basic amplifier and a frequency selective network. As mentioned already, there will not be any input signal. Okay. So by default, some amplitude will be created because of noise. I will explain it quite later. Okay. So Xi is going to be the mixture output, right? And X naught is the output. Here we will be having a sampler which will samples the output and give back as the feedback signal in the form of XF. Coming to the Bar-Cousin criteria. If an amplifier to work as an oscillator, it should satisfy Bar-Cousin criteria. So consider an inverting amplifier. What is an inverting amplifier? If I am giving a signal like this, that is having a positive half cycle followed by negative half cycle, it will be producing an amplified output with a negative half cycle followed by a positive half cycle. That is, it impacts 180-degree phase shift between the input and the output signal, right? So that 180-degree phase shift is achieved in your basic inverting amplifier. But I want the actual input, that is, I should have 0-degree phase shift. If I'm getting a plus 180-degree phase shift, that has to be compensated by minus 180-degree phase shift. Or in other words, I can say the sum of the total phase shift around closed loop, right from the input, basic amplifier, output, feedback network, back to the input, the phase shift should be 0-degree or 360-degree. So for that, what we are going to do in the sense, X naught is going to be A times of input. We know that beta is equal to xf by x naught. Okay, if I'm going to substitute this in this, okay, this can be satisfied only with minus a beta equal to 1. So if we take the magnitude on both the side, modulus a beta would be equal to 1. So what is the meaning in the sense? The phase of xf must be equal to that of xi. That is, the feedback network introduces a phase shift of 180-degree in addition to that of the inverting amplifier 180-degree. And therefore, the total phase shift around the closed loop will be 0-degree or 360-degree. The next property is the magnitude of product of open loop gain and the feedback factor will be always equal to unity. So this Bar-Cousin criteria is most essential for any amplifier to operate as an oscillator, right? So depending upon this product of open loop gain and the feedback factor, we are having three types of oscillation. So this is actually the Bar-Cousin criteria states. Okay. So this results in self-sustained oscillation. But we may have a condition that modulus A beta can be greater than 1 or it can be lesser than 1. So based upon that, there are three categories. One is growing oscillations. Here we could see as the time increases, the output is keep on increasing, thereby leading to modulus A beta greater than 1. Obviously, here we could see as the time increases, the output keep on decreasing, thereby leading to decaying type of oscillation, that is modulus A beta less than 1. And this is the condition for sustained oscillations. We prefer to use, that is, this growing type of oscillation is essential to initiate an oscillation, and the sustained oscillations is required to maintain the oscillations. So there are various types of oscillators depending upon the component being used in the feedback, depending upon the mechanism we are following, depending upon the operating frequency. Depending upon the nature of the output, we can have various categories. So based upon the mechanism, in the sense if it is going to make use of a positive feedback or negative resistive property. Depending upon the operating frequency, in the sense audio frequency oscillator, radio frequency oscillator, very high frequency, ultra high frequency, microwave frequency. Now the frequency has increased much better. Depending upon the nature of the output, it can be either a sinusoidal oscillator or a non-sinusoidal oscillator. Sinusoidal oscillator, in the sense it can be of square wave, sawtooth, triangular wave, right? The same sinusoidal oscillator can be again categorized depending upon the feedback element. One is the RC oscillator, the other one is the LC oscillator. Again, the LC oscillator is divided as Hartley oscillator, Colpit oscillator, even we can have tap oscillator. And this RC oscillator, depending upon the nature of the circuit, whether we have feedback in the amplifier or at the phase shift, we can have three categories: LC oscillator, crystal oscillator, LC tuned oscillator. And under the RC oscillator, we are having RC phase shift oscillator and beyond bridge oscillator. Here we can have crystal oscillator and parallel crystal oscillator. This will help you to understand the mechanism of how the oscillation is being created without giving any AC input signal. So already we have told a small fraction of the output is fed back as the input with the proper phase so that it will act as an oscillator, right? So here what happens, in the sense some noise will be actually generated. So if that noise is going to be the input of an amplifier, further the noise level will be increased. That is, the amplitude becomes larger enough to introduce non-linear effects. So automatically what happens, we need some equilibrium condition, that is we need some amplitude limiting conditions. For that case only we are coming up for the attaining the amplitude equilibrium condition by using some non-linear operations. Okay, the remaining part of this oscillations will be continued in the upcoming session. Thanks a lot.